Hello everyone, and welcome to this example recording on nodes, branches, and independent loops. So this example requires us to determine the number of nodes, branches, as well as independent loops in the circuit. Right, we'll remember from the definition that the number of branches is equal to the number of elements. The number of nodes is defined as a point of connection, or a node is defined as a point of connection between two or more branches, and a loop is any closed path in a circuit, whilst an independent loop is a loop that will have an element that is not part of any other element in another loop. So you must have at least one new element in the loop for you to call it an independent loop. So let's start off first with the number of branches. So we said the number of branches equals to the number of elements. How many elements do we have? 1, 2, 3, 4, 5, 6, 7, 8. Therefore, the number of branches must be equal to 8. Second, the number of nodes. So we've indicated the nodes as your point of connection between two or more branches. So how many nodes do we have? So there's a point of connection between 3 branches. 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 And finally, here is a point of connection between 1, 2, 3, 4 branches. So we should have 1, 2, 3, 4, 5 nodes. Right, and then finally, how many independent loops do you have? So you need to create loops in the circuit that will have at least one new element. So let's start with this, which we'll call loop 1. So loop 1 has element, let's call it element I1, I2, and I3. Right, so loop 2 has element I3, which has already been counted, but also element I7 and this element here. So it's got 2 new elements. And then this loop has these 2 new elements, so we can still call it an independent loop. And then if we look at this loop, this element, and this element have been counted already, but we have that new element that's there, so we've got 4. So we can then say the number of independent loops. So the number of independent loops will give us 4. Now we can always double check this. If you use your fundamental theorem of network topology, which says that the number of branches is equals to the number of nodes plus the number of loops minus 1. How many branches did we have? We had 8 branches. That equals the number of nodes, which is 5, plus the number of loops, which is 4 minus 1. And we get 8 is equals to 8, which is correct. So we could have used this to determine the number of loops. So we could have said the number of branches is 8, and that's equal to the number of nodes, which is 5, plus the number of loops minus 1. And from this calculation, we would have found that the number of loops is equal to 4. Thank you for watching this video and enjoy the course.